Hi, and welcome to the Web Talk on digital connectivity in wineries, reducing complexity and cost. My name is Chris Hoey, and I'm the Managing Director of Bürkert Australia. Thank you for the opportunity to talk to you today. Hopefully you enjoy the content, and of course we're available if there's any questions or you need to chat with someone after this. Okay, just to give you a little bit of history, Bürkert started in the wine fields of Baden-Württemberg back in 1946. Of course, we've developed a lot over that time. We're now in 36 countries around the world with just short of 3,000 employees. So in that time, we're still a family-owned company, and we're still pioneers and leaders in the world of technology and how we can apply value to our customers. Today, we're going to look at the different connectivity systems that wineries have used in the past and also the more modern systems. We're going to look at an example system comparison. And we're also going to look at how we connect with other systems in a winery. Generally, when you're looking at automation, there are three different ways that you can connect automation systems in the field. The first one was centralized, where we obviously ran everything to a single point, distributed, where we put field boxes, and then we brought those to one point, and then, of course, the latest being decentralized. Let's look at centralized. You may recognize some of these systems in wineries where everything was brought back to a central point. Systems were engineered not to be changed, just to be run. This always led to high complexity, whether using temperature controllers or PLC systems, still a lot of terminations, a lot of cabling, and a lot of work to be done to install such a system. We then, of course, over time moved to distributed systems, and these could be in temperature control panels or what's more widely used these days, bespoke engineered solutions for multiple tanks, maybe 16 or 24 tanks, all wired back to single panels in the field. These were then network connected, where we could bring them back to the central point for control. Even these still had very, very high requirement for lots of cabling and lots of installation. We always ended up with a very happy field technician. Why is he happy? Well, he just secured a lot of work that he's going to be doing to install these systems. And that's going to be, for you, a lot of cost. But this has all changed now with digital connectivity. We moved from a system where we have these strict layers of communication where everything only communicates with the level above or below, and you end up with lots and lots of, how can we say, interfaces, to what we see now is interconnected systems where everything plugs and plays and communicates with everything else in the field. So in other words, your ERP system or even your cloud system can communicate directly with I/O sensors in the field. So you see the similarities when we look at decentralized to the more modern connectivity systems. So how do we realize this? Well, we may start with something like an IP67 block, which has all M12 finger-tight connections. So we could use that with IO-Link or bus or other networks. We then reticulate power. We bring the Ethernet directly to the field, and we loop on to the next one, to the next one, to the next one. And of course, we plug in our sensors and valves as required. So it gives us the ability to interconnect and build systems with no panels and no wiring to be done at all, apart from twisting some M12 cables. So it might look something like this, so you can see the reduced complexity compared to those drawings before. Let's look at a real example system. In this system, I've got just 12 tanks, and I've got on each tank an RTD sensor, a brine valve, and a product valve. In this case, a butterfly valve with feedbacks because they want to do pump safety, etc. So how would we wire that in the traditional way? Well, you can see here, wiring that all back to a central panel is going to take a lot of cables and wires. This means lots and lots of design engineering, lots of drawings, lots of cable runs, lots of ducting and cable trays, etc. in the field. And as I mentioned before, very happy field technician for the amount of work he's going to get. How future-proof is this? So when we still design and build systems like that, we need to be thinking about how it's going to fit into this whole Industry 4.0 or IIoT solution. And a little scorecard here. do we get seamless integration of process data? The answer is no. We don't get advanced diagnostics on anything in the field. We don't get things like change in run and able to swap out a sensor or a valve, and also asset management is not available. We end up with lots and lots of bespoke engineering and very expensive panels to be built, and a very, very high installation cost. And one would question, people think these old systems are simple. They end up being very complex in their physical design. Now let's look at digital connectivity, where we replace all of those cable trays with simple M12 IP67 cables. This is the same 12 tanks now installed. We've installed just one IP67 block in the diamond between two tanks. And you can see we just run M12 connectors running each of those field sensors and valves. So lot simpler in their system. And of course, the only wires you're running are power and data. How is it with future proof? Well, we do get seamless integration of process data. From the temperature sensor at 21.6 degrees, it is 21.6 degrees right throughout the system and right up to the cloud, if you like. We get advanced diagnostics. We can tell you exactly how many cycles a valve has done. We can tell you if it has cut short its travel or there's any issue with it. We can change out a sensor on the move without having to call a technician, etc., by simply unplugging and replugging the M12 sensor. And importantly, we get asset management. Now, we've never had this in the past, but one could consider if you've got hundreds of tanks, you may end up with thousands of devices in the field, which could end up being a lot of cost. The ability to actually know what's installed in the field and to be able to know what to reorder, how to get spare parts, etc., becomes a huge cost saving for long-term maintenance. In price position, well, this ends up being cheaper than previous systems because there's no need for bespoke panels and things, as well as installation becomes a fraction of the cost, which I'm sure you'll see. And simplicity is certainly there. Just an example on this. This is a screen grab on the right from an ignition SCADA system. Now, what we've shown here is that nothing to do with the control system on this side, but the ignition SCADA system can also immediately communicate directly with the valves and sensors in the field and showcase their asset management and diagnostic data. So in other words, you don't need to write or program all this in your PLC. This can actually be drawn directly from the sensor. That's what that interconnecting system is all about. So let's not just take my word for it here in the presentation. Let's put it to the test. I've got a couple of colleagues here who are going to help me, and we're going to put the challenge to them to wire up systems in both ways.
Hi, I'm Chris Hoey. We've spoken a lot about digital connectivity, but today we're going to showcase how we can actually put that into play. What we've set up here is a generic wine tank application. On the left-hand side, we've gone for traditional wiring, so an RTD, a brine valve, and of course a butterfly valve, which could be used for pump in, pump out, etc. On this valve, we've also got feedbacks for pump safety and the like. We're going to wire this directly to a control panel and showcase the traditional way that most wineries would be automated right now. On the other side, we've got the digital connectivity version, where we've got the same devices identical to this side. However, we've gone with digital sensors and digitally communicating valves. And we're going to wire those directly to the control block on the top. So what we're going to showcase is the difference between the two systems, and we're going to have a bit of a timed trial to see which way's faster and which way's better to communicate. It's not entirely fair because in a control panel situation, we'll be wiring just to the panel at the tank, whereas in a real situation, there may be one panel per 16 tanks. So this panel could be up to 40 meters away from the actual things that we're wiring. So every cable that we put in on this side could actually be up to 40 meters longer with cable trays, ties, etc. So, but in this instance, we'll just wire it directly to the tank here. Both sides, we're assuming we've got power and comms connected. So I've got a couple of helpers from our team who are going to have taken on the challenge to compete in this showcase. So I'd like to welcome them now, and in true MasterChef style, I would like to say your time starts now. So on the left side, we've got Nelson. Say hi.
Hey, Chris.
So just to give us a bit of an idea, how are you going to go about this?
Yeah, so what I'll be doing first is obviously running the air tubes from the valves to the control panel. I'll then rough in my cabling, so that will mean cabling to the RTD and the control valve back to the control panel. Once all my cables are roughed in, I'll then terminate in the field and finish off by terminating in the panel and see how we go.
And how long do you think that's going to take?
Probably about half an hour, just given the type of job it is and what I've done before.
Okay, so on the digital side, we have Nicholas. Nicholas, can you just give us a bit of an overview as to what you're going to do?
Alrighty, so first up we're going to connect our pneumatics for our valve heads. So the nice thing with these heads is that we're using pilot valves, so we don't have to run individual air lines to each valve. We can just loop between each of the control heads. After we have our air lines in, we're going to be running our digital connectivity cables from each of our devices on the tank back to our field gateway module here. Once we've got that all set up, we're then going to generate a file so that the PLC can interface with all of our devices. Okay, and with that, we're all finished and ready to go.
All finished already?
All finished
okay.
already.
Okay. Well, let's maybe put it to the test, okay? Let's auto-tune this valve.
Yep, alrighty, so if we jump into our butterfly valve there and we run our teach function. Cool, and we can
valve's
see that
operating.
The valve starts teaching.
So the teach function is setting up all of the end positions and the feedbacks, etc.
That's correct. So it's teaching that head whereabouts the bottom and top of that valve body are.
Can you tell me what the temperature is?
Yep, no worries. So we're just waiting for the final teach for this one. And now that that's finished, we can see that our temperature is 23.4 degrees.
So 23.4 degrees on the temperature. So we've actually successfully commissioned everything.
Yes.
One of the beauties about digital technology is that we don't just get feedbacks and things like that, but we actually get more diagnostic data, etc. Can you actually tell me how many cycles this valve has done in its entire life?
Yep, no worries. So that's easy as well with these digitally connected valves. So jumping into our diagnostics for the valve head, we can actually see that the valve has done a total of 1,845 cycles.
So 1,845 cycles. So we can actually set points on that so they can actually tell you when a valve needs servicing or replacement, etc.
That's right.
Can you tell me the ID number of this control top and when it was manufactured?
All right, so jumping into this device, we can actually see all of the maintenance data for it. And the ID number for this one is 307376, and it was manufactured on the 11th of June 2019.
There you go. So this sort of data is just standard when you have digital connectivity. Of course, you get none of that when you have an alternate wired system. Well, you're all clear then.
Awesome.
Let's see how Nelson's going.
done.
You're done.
Done, Chris.
It's about time. So you're at what stage now?
So what I've done is basically the terminations at the board, ready to do my point-to-point testing. So we've not done any configuration, whatnot just yet. That's all for the PLC team. But yeah, we basically need to now check our wiring. It's probably going to go through a few tests, check for any issues with wiring, and then we can start worrying about the configuration.
Okay, so where Nicholas got up to is a lot more advanced as to where you are right now, because you've still got to do your point checks and generate that file for the PLC to communicate. Yep. About how long would that take you to catch up?
Probably about 10-15 minutes, just based on what we have here, roughly. So.
Okay, so another 10 or 15 minutes. But I think we'll call it there.
Cool.
So there you have it. You can see there's a big difference between what the guys did and what time they had and where they're up to. As Nelson said, he's got another 15 minutes or so to go to get to the same stage Nicholas was already at. I think we've given a great showcase today of the differences between the traditional versus the digital connectivity. And our example today has shown that we're 15 to 20 times faster to do the field work and also prepare for the PLC communication by doing it digitally. So I hope that this gives you a great idea as to why and how this can save you a lot of money. This was just one tank. In a real winery, there may be up to 200 tanks. So it's going to be a big difference in the costs of a project.
Okay, so you see the difference there between the two different connectivity systems. Certainly, we've learned around 15 to 20 times faster to install a digitally connected system, which makes it a much, much lower cost for a large installation or even a small installation. But projects don't always go as planned. Let's just say on our application here, the winemaker comes along and says, I want to add tank blanketing. So I want to add a solenoid valve per tank. So something as simple as a solenoid valve, now we have to consider, did we allow for that in our initial panel design? In other words, do we have enough outputs? Do we have enough terminals? Do we have enough size? Do we have enough room? Looking at the panel we're using here, the answer would probably be no. So you may even need a second panel to be built. So you end up needing a lot more engineering, a lot more drawings, more cable runs, more 40, 60 metre cable runs on cable trays, and once again, very happy field technicians. Now let's consider that in the digital connectivity system. Our winemaker has come along and said, I want to add tank blanketing. It's as simple as adding a few more interconnecting cables. So plug and play, integrate it to the system, communicate with the control system. Now, how would an application like this look in real life? Well, this is a real life winery where everything is connected on that single digital connectivity. And you can see examples here. Like on the right, the top of those tanks, there's only one cable running up there to connect all of those different valves. So a lot simpler than having to run cable trays and the like. But what about connecting with other systems? Well, we may also need to connect with our winery management system or ERP. We also may need to connect with existing systems or PLCs that are already on site. Well, all of these systems are open platform. In other words, they can communicate with any different system or network you've got. So it doesn't matter if you're using a Rockwell or Allen Bradley PLC, Siemens, Schneider, or whatever. Generally, we can set up the protocols so that we can integrate directly into those systems. And what about communicating with, whether it be your ERP system or right through to cloud-based systems? Let's just say you want to store all the data from your winery and just throw it up to the cloud so that next year you can have a look at exactly how you made that particular product or system. So this is where we can interconnect with all of those different systems, once again using open protocols that communicate with all of these different options. So you can see there's quite a lot of openness in these new open systems. So in conclusion, Bürkert is an ideal partner for winery automation. We've always been renowned for proven field hardware competence, leading technology and process control, but now offering smarter installation techniques, reducing total cost, and of course, future-proof and open communications. Thank you for listening today. I hope it was enjoyable for you. Of course, if you have any questions, we're here to help. Thank you.